Good morning. My name is Niyati Rolia, roll number 23 from Division A, and my topic is Cloud-based solution for improvement of response time of MySQL RDBMS, published by IEEE. Let me first introduce my topic, that is improving the response time. For any database server, performance is the essential thing, and to function it properly, four fundamental resources are used: CPU, memory, disk, and network. If any of these resources is weak or overloaded, then a database server is very likely to perform poorly. This is because the physical address limit on Windows 32-bit is 4 GB, and the default settings within Windows is to split the virtual address space between kernel and user applications to GB each. Suppose Windows system have about 4,000 ports available for a client connection, and after a connection on a port closes, it takes 2 to 4 minutes before the port can be reused. In such environments, where client connects and disconnects to and from the server at a high rate, it is possible for all available ports to be used up before closed ports become available again. If this happens, the MySQL server appears to be unresponsive even though it is running. On the other hand, the amount of data produced by the user in the last few years is enormous. The systems that are running on MySQL are not really suitable for handling big data. Usually, the response time increases radially. Therefore, a cloud-based system is used. It provides a lot of advantages like fast automated recovery from failures, better performance, scalability, elasticity, etc. Also, cloud computing has brought remarkable changes in IT industries. Therefore, response time of system is improved by combining MySQL and cloud with necessary conditions. Now, the combination includes three parts. That is, the methodology includes three parts: data migration, uh, technical specification, and migration proposition. Now, what is data migration? Migration from MySQL to cloud requires huge reengineering. If we migrate the database from MySQL to cloud, there will be a development cost, which may increase depending on the system complexity. More importantly, not every system is suitable for migration. The system that only use big data should use cloud. Combination will not be beneficial if the system do not use big data and metadata at the same time. Here, the metadata means the information we get by analyzing big data. We can reduce re-engineering cost by combining MySQL and cloud. System will perform all the regular functionalities to collect data from clients and store them in MySQL. Data validation, concurrency control, constraints, definition, security management issues, etc. Nothing will be changed. The only thing that needs to be noted is the transfer of data from MySQL to cloud after a specific time period done by system admin that determines what type of data must be transferred to cloud. As the data transferred as the data is transferred to cloud, query related to those data is also submitted to the cloud. The next part is technology selection. Before that, let us understand what is necessary to the conditions include. Not every system is suitable for this solution. The systems that use metadata and huge client data are only suitable for combining MySQL and cloud. Your client data and big data is the same. As cloud performs better on big data, metadata should remain in MySQL. Some systems use client's data for further analysis and produce business reports or statistical outputs. This type of data should also remain in MySQL. The selection of cloud technologies should be done based on kind of system being used. The few technologies of cloud are Hive, Big Latin, HBase, etc. Hive provides data warehousing facilities on top of an Hadoop cluster. It supports parallel processing. Query language, popularly known as HiveQL, is used by Hive, which is very much similar to SQL. User can create tables and store data in Hive just like MySQL. It provides various tools for easy extraction, transformation, and loading of data. Hive is good for analysis. Therefore, system that requires analyzing data and generating reports can use Hive. Big Latin is a data flow language. Programmers write scripts to process data. Data is processed using parallel processing technique. Data is loaded to cloud before it is processed using Pig. It is suitable for those who would like to use cloud as per demand. Therefore, and data will be loaded to cloud using Pig scripts. HBase is a database that is used to store and retrieve data. HBase enables fast read and write functions with scalability. Thus, HBase should be used when system needs random real-time read-write access to big data. It can be also used for online processing system. Next, system migration proposition. Here you can see a flowchart which describes the process of migration. The data migration must be done very much carefully and efficiently as it is the most important step. Therefore, errors must be checked. In the flowchart, the term upload time used determines the system is determined by the system admin. Upload time is the time when MySQL table data will be migrated to Hive. During the configuration time, the system admin must set the value of upload time. So this will also determine the frequency of data migration from MySQL to cloud. When the system starts, it will first check whether upload time matches the current time. If it does matches, then all the data is temporarily stored in CSV files. Hive can read data from CSV files very easily. After successful data transmission or migration, data will be deleted from the MySQL as well as CSV file. To test this theory, a demo project was used of patient health history management. And this experiment was done on data ranging from 1200 to 3,09,600 size. In this experiment, following tables were created: user, doctor, health history, medical reports, user summary, and health record summary. Each data had attributes like ID, first name, last name, in user, doctor, qualification, experience, etc. Health history included type of disease, date of issue, etc., etc., etc. For this experiment to conduct, following machine configurations were needed: MySQL application server of Apache Tomcat 7, processor of 2.20 GHz, and memory of 4 GB RAM. For Hive, two laptops were used of 2.20 GHz and 8 GB RAM. This experiment was conducted using three queries, where in first and second query you can see that MySQL time is increasing at certain point where the size of data has increased drastically, whereas the time taken by Hive Cloud is almost stable with the increasing of data size. Second graph is also similar to the first graph, whereas in the third graph, MySQL takes much lesser time than the Hive. So what these three queries comprised of? In first query, three joins were used to display data of patient's health history and all medical records related to the patient. Surely this type of query will have to handle the big data situation at some point of time. The query response time for both MySQL and Hive was tested and was known that MySQL performs better for smaller table size, but when the size grows with time, Hive starts to perform better. When the data size is greater than 2,08,800 records, Hive response time is better than MySQL. In second query, two joins were only used to display list of patients treated by a specific doctor. This was a much simpler query compared to the first, but here also big data situation would arise. When the data size is nearly 2,59,200, Hive starts performing better than MySQL. The third query, no joins were used as it was done on the metadata, whose record size is very small. From this analyzed data, we got the statistical information. The query was the simplest one, not a big data related query. It was supposed to get a number of cancer affected patients. Therefore, the table size not being big, MySQL took only a fraction of a second to respond, whereas Hive took more than 5 seconds to respond. So, to conclude this experiment, I must say that being MySQL and open source RDBMS to store and manage data, it faces difficulties of prolonged response time while handling big data. On the other hand, cloud is a perfect solution for managing and querying big data, but it is not suitable to process small data due to delayed response time. Thus, a cloud-based solution that will improve response time and performance of system to handle big data as well as small data by combining MySQL and cloud to store and manage all the data was being proposed.